Doing? This is Dr. Nandi. For those of you who do not know me, I frequently go live on YouTube and I work out problems in math. I have also a channel, YouTube channel, where I have solved all kinds of math problems and I frequently lecture there. So please take a look at my channel and subscribe to my channel by hitting the red subscribe button. And today I'm going to talk or solve a problem on relative frequencies of different years of survival for chemotherapy patients. First column, the years they survived, and the relative frequency or proportion of different categories of years of survival. So we will plot a relative frequency histogram. Now in a histogram, we have relative frequency on the vertical axis and the different groups of data on the on the horizontal axis. So relative frequency, REL stands for relative frequency on the vertical axis. As you can see, the lowest relative frequency is 0.02 and the highest is 0.42. So we can divide the vertical axis into intervals of 0.1, 0.1, 0.2, 0.3, 0.4, increments of 0.1 on the vertical axis, and then 0.5. So this is relative frequency on the vertical axis. On the horizontal axis, we'll have the different groups or classes of data. So the first class is between 0 and 2. 1.99 it ends, the second class starts at 2. So this is between 0 and 2. So we have years of survival on the horizontal axis. Okay, so 0 to 2, then 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14, and then the last one is 16, 14 to 16. Okay, so the relative frequency in the first class is 0.1. This height. The next one is the highest relative frequency, 0.42. So slightly more than 0.4. So I look at 0.42 on the vertical axis. The next class is between 2 and 4 years of survival. So I will draw the horizontal line at 0.42 and then make a vertical bar to indicate the relative frequency of the group of data between 2 and 4 years of survival. So the height of this bar, as you can imagine, is 0.42. Now you get the picture. On the horizontal axis we have the different classes or groups of years of survival, and on the vertical axis we have the corresponding relative frequency. Each class, the relative frequency is indicated by a vertical bar drawn on top of it, like the height of the bar between 0 and 2 is 0.1 because the 0.1 because the relative frequency in the first class between 0 and 2 is 0.1. The next relative frequency for the second class between 2 and 4 is 0.42, so the height of that bar is 0.42. Next one is 0.02 relative frequency, that is between 4 and 6. Now 0.02 will be really small. So this is 0.02. The height is 0.02. This height is 0.02. That is the height of the next vertical rectangle. Next one height is 0.1 relative frequency, so it's over here. So this height is 0.1, which is the proportion or relative frequency in the class between 6 and 8. Now between 8 and 10, this is 0.04. So the height of that bar is 0.04. So it will be somewhere over here. 8, this height is 0.04. Again, the heights of the bars are the relative frequency in each class. Next one is 0.06, that is between 10 and 12. So it will be slightly higher than 0.04, something like this. Okay. Next one between 12 and 14 is 0.02. So again, this will be like this. And the last one between 14 and 16 is 0.2. So 0.2 is this height is 0.2, relative frequency between 14 and 16. Now this is the relative frequency histogram. So again, on the horizontal axis you have the different groups or classes which are years of survival of chemotherapy patients. On the vertical axis you have a relative frequency or proportion of data in each group or each class, such as the first class, which is between 0 and 2, proportion is 0.1. Hence the height of the bar on top of it is 0.1. Okay. The height of between 2 and 4 is 0.42. Height of that rectangle is 0.42. Next one is 0.02 and so forth. Again, the heights of each bars, adjacent bars, heights of the bars indicate the relative frequency. The width is each class. So between 0 to 2 is the first class. This is your first class. This is your second, third, fourth, fifth, sixth, seventh, and this is the final class between 14 and 16. These groups of data are called classes of data. Now we can join the middle of these roofs. Try to be a smooth curve, which may not be possible, but we will try our best. Middle of each roof you can join a smooth curve, which is like this. Okay, so this curve is obtained by joining the middle of each curve. We missed some of them, but it is supposed to be a smooth curve which joins the middle of each vertical bar, middle of the roof of each vertical bar, and this is called a probability density curve. Probability density curve, which is obtained by joining the middle of each roof vertical bars. Okay, probability density curve. One thing to remember, the area under the probability density curve is always 1. Okay, so but the frequency histogram, relative frequency histogram, is basically the bars touching each other, and the heights of each bar are the relative frequency in each class. And then we can join the middle of the room. Sometimes we'll get a smooth curve. Most of the time we get a smooth curve. Here, because the relative frequency in some classes are really low, some are really high, we are not getting a smooth curve. But still, that curve, which is the smooth curve joining the middle of the roofs of each of the vertical bars, is called the probability density curve. And the area below the probability density curve is always 1. Okay, so I will stop here today. If you have any question, comment, write me a note. I'll get back to each one, each and every question that you ask. If you like this video, please give me a thumbs up. That really motivates me to produce new videos which are of interest to you. And I appreciate the fact that you took time to watch my video. If you like this video, give me thumbs up. If you like this video, share with your friends. And please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. Have a nice day. See you.